Bro, that's pretty cool.
Okay, you guys, let's try again. Quiet, please. Thank you, recording. Thank you. All right, so I did 0, which is -5. Do you get that, Lizzie? And then 1 and -2.
Sir.
And then I did a negative. I did a 2 and 1. And then -1 and -8. Okay, so 0, -5 is right here, right? So 1, 2, 3, 4, 5. I think I count. I mean, maybe you counted wrong. Do you count wrong, Lizzie? There you go. Hold on. 1, 2, 3, 4, 5. All right, then 1, -2 is right here. 2 1s right here. And -1, so that's -6, -7, -8. Yeah, we're okay. There we go. Okay, so there we go. You got this line, right?
Yeah.
Okay, cool. Good. Now, here's the deal. This is the part I need you guys to really focus. So when you have an inverse, right? That's the inverse. That's a symbol. Well, I don't like that anymore. It's a freehand. When you have the inverse, you simply switch x and y. Now, if you wanted to, if I were to plug in -5, I mean, go ahead and plug -5 into this, right? If I were to plug in -5 in, what would happen? You have 1/3 times -5, which is -5/3. Add the 5/3, you get 0. But you don't really need to do that because you know it's an inverse. You can just switch all the x and y coordinates. But go ahead, if I plug -2 in, I'll have -2/3 plus 5/3, which I know is 1 anyway. It helps if you could. It's not a big deal. 1 and 2, and -8. -2/3 plus 5/3. What's -2/3 plus 5/3? It's 3/3, right? No, you thought it was positive. So anyway, when I plot these points, here's what happens. -5, 0. Let me count it carefully. -2, 1, which is right here. 1, 2, which is right here. And -8, -1, which is way down. So that's -6, -7. 6, -7, -8. Sorry, no, it's shoot. Yeah, just a little bit, right? All right, let me draw a straight line. So it's kind of like that, right? So here's what happens. This is the part I want you guys to focus on. Yes, exactly.
You're so smart.
They do intersect that. Well, close. Is that right? Okay. Well, it's not. I think it's actually none of those. But
Well, we have rulers for this.
this is more of a learning, not a testing. There's more learning thing. Okay, so the green line I just drew is y equals x. This is the part that I need you guys to really focus on, and I'll emphasize this again after break. But the original function and its inverse will always be a reflection about the line y equals x. Just, I don't know, just a grammar, it's a preposition, I don't know.
So it'll just be
I don't know how to answer that question, sorry.
the same English class, all right?
I mean, if actually, no, you know what? No, I know what you're asking. No, Isabel's asking a really good question. So what if I took out? Okay, so here's what I drew, right? What if I took if I took a pair of scissors, right, and cut out the square graph. If I cut this out, let's say it folded about y equals x. If I folded this square piece along y equals x, what happens to the blue and red lines?
It doesn't look like
Big touch, right?
They would map onto each other. So what happens is that the blue. No, I mean I understand the question you're asking. The blue and red lines are symmetric about the green line. That's what's happening there. They're always going to be symmetric about that green line. That's what will always happen with inverses because you switched X and Y. Because you, so if I were to cut out a square piece of paper and draw a diagonal, like Y equals X, and folded the piece of paper along that diagonal, the blue and red lines would map onto each other. That's what's happening with inverses. Let's try it again. Let's move on to the next example. All right. So Y equals X squared. Let's plug in these numbers: 0, 1, -1, 2, and -2.
I have a question.
Yeah, go ahead.
Would the inverse of that just be like X rooted?
Yes, it'd be X equals root Y. Actually, hold on. Sorry, let me back a little bit. First of all, X would equal Y squared, and then Y. Yes, Y would equal, but you gotta say plus or minus.
Okay.
Like plus or minus because of the square.
Yes, exactly right.
Yeah.
Okay, but let's not worry about that for now, because that this is the original. This is the original. Okay, let's just focus on the original, guys. Okay, that's what I was doing before I got asked another question. It's okay. No, it's good, but I just confused the rest of the class. That's all. So let's focus on the original. Y equals X squared. Let's plug it in. If I plug in 0 into the original, what do I get? 0, plug in 1. -1, I get 1, 4, and 4. Okay, let's plot those points. That's easy, right? Not that hard. And you guys did this last semester, right? I mean, graphing parabola is not hard. Now, the inverse. The inverse means you switch the columns. You do a little switch. Sideways. Sideways.
Oh, what? I'm so how it does that.
Now, this is the part that I was saying earlier about the reflection or the symmetry. Okay, see this green line I'm drawing right now?
Yeah.
If you were to cut out a square piece of paper like this, if you were to cut this out and fold along the dashed green line, what would happen to the blue and red curves? They would map onto each other. That's all I'm just trying to point out, is that that's what happens with inverses. That's all. It's just an observation.
That's kind of weird.
So always you would expect this. Now, if you were to actually find the inverse, yes, you switch X and Y in the equation and you isolate Y, which would be this. And if you look at what I wrote in red in the table down below, it satisfies that green equation, right? If I were to plug in 0 for X, I get 0. Plug in 1 for X, I get 1. Or you get -1 plus or minus. So plug in 4, I get 2, but plus minus 2. Exactly. If I wanted to write the inverse equation from the original function, sure. Because I had to switch X and Y and solve for Y. But what I'm also trying to show you guys too is what happens graphically with inverses. We did it. Exactly. That's it. Just switch the numbers and plot the points. Yep, that's it. As we should, because that's how you did algebraically, right? Algebraically, we switch X and Y, so you do the same thing graphically too. So I'm just trying to show you graphically what's happening as well. Now, you guys might remember something called the vertical line test. So if a graph passes the vertical line test, then the function, then the equation of the graph is a function. Yes, the equation of the graph Okay, the equation of the graph would be a function. So if you look at the blue line, right? I mean, the blue curve. Remember, guys, remember vertical line test? You draw a bunch of vertical lines, right? So you see how like the blue curve is a function, right? So yeah, of course, y equals x squared. And to be a function for every input, that's to be one output. So every input's unique,
Oh, yeah.
For blue. But the red curve is not. The red curve is not. So the next one is talking horizontal line test, right? So I'll just have to clear this. The horizontal line test says the following, that if graph passes the horizontal line test, then
Is it just is not a function?
then the inverse of the equation of the graph is a function.
How do you do these again?
Let me draw the graphs again.
Oh,
Let me just draw it again. Hold on. So this is what we had for the original, right? And this is what we have for the inverse. The original. The original. So if I were to draw horizontal lines now, do I touch more than once?
oh, it's just not. Okay.
So that means that the inverse is not. So it means that that's not a function. Because look at the red curve. Does the red curve pass the vertical line test? No. So what you could do in lieu of doing the vertical line test for the inverse, you do the horizontal line test for the original to see if the inverse is a function. That's all. That's all it's telling me. Okay, let's do a couple more here, and then we'll be done for today. All right. Okay, now at this point, we don't really need to find the inverse because we kind of know we're just switching x and y, right? So it's just kind of redundant. Like if I plug in 0, I get 0. If I plug in 1, I get 1/2. If I plug in -1, I still get 1/2. What if I plug 2 in? I should get 2. -2, I think I still get 2. So you get 0, 0. Yeah, sure, good. Oh, you're right. Shoot. Thanks. Oops. Good catch. Okay, let's try again. 0, 1. We'll just do 3 points. Yeah, my apologies. I didn't see that. Thank you for catching that. Yeah, we won't do 5 points. Okay. So let's plot that. Yeah, because you had to follow that domain. My fault. Now let's switch it up. So you switch these coordinates. So 0, 0. Now doing 1/2, 1. So right there. And there you go. There's the inverse. So the red was the original. That's the original. The green is the inverse. And always, 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 let me get a straight line here. I'm going to connect. Whoa, that's not a straight line. Here we go. There we go. Does that pink line cut those two graphs in half? Yeah, totally. It goes right through the middle, right? So that's what's meant by the symmetry or the reflection of y equals x. It's going right through the middle of those two graphs. Yeah, actually, great question. Let's talk about domain and range. So the domain for we'll do this for the original. Yeah. So x is greater than or equal to 0. And my range was y is greater than or equal to 0. But actually, by looking at the graph, if you look at the graph, what's the lowest x value for the 0, and then we have to go higher than 0 because you're told to do so. And then the range, what's the lowest y value? 0, and it just keeps going up.
Would the range depend on the inverse of the graph?
Yeah, yes. What you do then for the inverse.
If it's just like x is greater than or equal to 0 for like regular function, but if you y is greater than or equal to 0 for the inverse.
Yes.
As well as if
Yes. Yes. This is something we'll talk more about after the middle of March when we get to chapter 7. But the inverse, you would swap the domain and range, right? It still be the same because if you look at the green curve, it's still the same thing, right? Because it does start at 0. So for my inverse, my domain is still x is bigger than or equal to 0. My range is still the same thing.
The range will always be the same for both.
For this particular case, yes, it could change. Well, let's look at another one. Let's move to example 4. Okay, y equals x cubed. So I'm going to say plug in like 0, I get 0, 1, I get 1, 2, I get 8, -1, I get -1. Yeah, totally. So you get 0, 0, 1, 1, and see 2, 3, 4, 5, 6, 7. It's like totally off the curve. Yeah, it's kind of hard to draw. And then if you simply do a swap, 0, 0, 1, 1, 8, 2, -1, -1, -8, -2. So it kind of looks like this. Yep. And I kind of like to write this. Kind of looks cool. Just means all real numbers. Maybe a little line through it. And same for the inverse. But with the inverse, if you were to solve it, we y equals cube root of x. If you were to solve it, that's what you would get. And again, if I draw the line y equals x, it just cuts this in half, right? It creates that symmetry between these two. Okay, one more, and we're done. Then I feel comfortable that we're not going to fall behind. Now, this is where domain range matters a lot because there's a square roots. It actually, we have to pay careful attention here. What's the lowest x value I could plug in? Yeah, good. You can do -2, and then I'll plug in -1 and 0. And maybe 2. So I'll do 4 points. So I get 1. No, oops, I get 0. Wait, why did I do 0? That's dumb. Hold on, let's back up a little bit. We'll do -2, -1, and we'll just do 2. That's good enough. So I get 0, 1, and 2, right? That's easy. -2, 0, -1, 1, and 2, 2.
How can you plug in -2?
-2 plus 2, 0. Square root 0, 0. 0 times 0, 0. Right? All right. Then next up, you have 0, -2, because you're going to switch, right? 1, -1, 2, 2. So 0, -2 is right here. 1, -1 is right here. And 2, 2. So it looks like that. So see how it goes right through the middle. Now domain for the green, for the original. Yeah, it starts at -2 and goes forever in that direction. What's the lowest y value for the green curve? Just look at the graph. The lowest y value for the green curve,
Oh, it's 0.
0. Now let's do it for the inverse. This is the beauty color coding.
In whatever, like,
You have
in-
to
in
write,
implementation, you like-
the latest proposal, are you gonna ask us?
Oh, yeah, I think it's just more for the stuff that we're gonna do down the road, because I'm gonna ask you to do domain range for future functions. This is more for like notes, not so much a test situation. This is more just for your learning. That's all it is. Let's go go. Yes, yes. Like for example, let's look at the green. So let's look at the red curve now. Where's the red curve start at 0, right? And you're going higher. And then what's the lowest y value in the red curve? And it's going up. Now notice that these the reverse, right? Like here's -2 and 0, but here's a 0 and -2, as they should be, because they're inverses, right?
in your implementation, have you read the ice cream?
You do bracket 0 then infinity, like that. Yeah. So anyway, that's just the learning part. Want to make sure I at least talked about it. It's 11 o'clock. We got about, when do we get break for lunch? 15? Okay. So let me locate some problem sets for you guys. Okay, and then we'll no, because we're gonna revisit this after break. No, you guys need more review for the test, so yeah, fine, go. I'll I'm gonna turn off my projector. Sure, yeah.
This time I'm not. This time I'm not doing it, so I'm keeping in mind.
Can't wait to go home.
What's a bad mindset?
Oh my god, my next 2 classes are finished.
Wait, one next week?
I got English and then religion. You have an English quiz though.
Oh, the liquids is so easy.
Does he give you, he gives you the terms, right? You just have like.
He gives you like 10 terms.
Oh, asking?
So it's not like you can process. He told us that we could do that.